So we will just try this question what we are having here. Okay, it is the question I'm just taking again the a new type of question we can take. Introduction to counting we are trying to understand. Okay, so yeah, introduction to counting is our main, we can say, effort here, right? So a lot of times we faced so let me just mention the heading here, introduction to counting. Hmm. Introduction to counting. Introduction to counting. Okay. So whenever I say introduction to counting, so it means something related to combinatorics we are going to study. Let us see how combinatorics obviously will combine both things, P and C completely. A lot of time we faced with questions like how many different ways are there to do this. Uh, one way to figure out this out this one way to figure this out is to explicitly consider all possibilities and count them all individually in general. However, we seek to avoid that as far as possible. Why do so much work when you can do some smart math? And in this chapter we will learn a couple of methods to reduce the computational hard work. Okay, the question to ask here, why would I care how many ways are there? There are various reasons for you to care. Imagine I asked you how many ways you could jumble up a 3 by 3 Rubik's Cube. Sure, there's a lot. But a lot is hardly satisfactory to me. Knowing how many ways there are to do a certain thing quantitatively can be really useful in comparing different things. There are many ways of jumbling around 10 words in a sentence too. But it is more than or less than the number of ways to jumble a Rubik's Cube. These methods can tell you how likely it is that we get lucky if we start randomly. In particular, imagine we did this with passwords. Finding out the number of possibilities for a certain password can give us an idea of how secure it is. A lot of computer science concepts work only based on the fact that you are almost certainly not lucky. The same way it is really unlikely you jumble a cube randomly and end up a solved cube. Moreover, it can also help us estimate computer program will, how long a computer program will will take to run, as we will see in this chapter on algorithms. Okay. Apart from this, knowing methods of counting forms the addition and subtractions of combinatorics. A wide range of problems require some counting, just like math puzzles you may have done could require you to do some algebra. Besides counting the total number of possibilities without having to brute force through all possibilities is pretty satisfying and fun. They open up they open us up to new worlds of sequences with magical patterns and lots of ongoing research. Let's imagine three balls in a line. Okay, in how many ways can we order the three? Okay, let us imagine there are three balls in a line, right? So this is one of the ball. This is you can say again the other ball. Okay, and let us take one more ball here. That is sorry. Let us take one more ball here. One more ball I'm taking. Okay. So three balls I've taken now, right? Now from the three balls, what I'm saying is these are the three balls I've taken, correct? These are the three balls I've taken, right? So three balls I have taken. In how many ways we can arrange these three balls? Basically, they are asking. Okay. So in how many ways? Let's imagine there are three balls in a line. How many ways can we order the three balls? Ordering. So ordering part in a line we are having three balls. Okay. Right. In a line we have three balls with us. We have three balls in a line. In how many ways? Let us say this is the first ball, second ball, and the third ball. So obviously I can say that here. What I will do, one, two. This can be ball one, ball two, and ball three. So we can write ball one, ball two, ball three as one of the ways. Ball one is as it is, and ball three, ball two we can write. Similarly, ball one, ball three will be there, and ball two we will keeping here. It is ball one, and ball two, ball one we can write, and ball three we are keeping here. So ball one has moved to the second place also, and the third place also. Ball two has moved to the first and the third place also, and similarly ball three has moved to the second and the first place. It should move. So these are the ways I can say. In many ways, the most obvious approach to solving this problem is to try to brute force through all possibilities. So we have one, two. In all, there are six ways. Okay, six ways of doing so. So ball one, ball two, ball three I've kept. Ball one, ball three, ball two I've kept. Ball three. Okay, ball three, ball two, ball one I've kept. Okay, so this there should be some more ways as per my understanding. So ball one is there on the first place again, and iterations are there. Ball one has also gone to the other places. Ball one I think we have completed. For ball two, we have kept here again. I think here, and iteration to the first place and third place is also done. For ball three, we have kept at the same place, and iteration to the other places. Ball three and ball three have kept here. So what are the other possibility here? ball 1 can be kept somewhere else or what? Ball 1 has been fixed in the first part, and 3 1. So we have 1 2 3 1 3 2 3 2 1 2 1 3 3 1 2 3 1 2 is there or not? 3 1 2. Have we done ball 3 ball 2 3 ball 2 ball 3 ball 1 ball 2? So we've not done that. Ball 3 ball 1 ball 2. Okay. Ball 3 ball 1 ball 2 we have not done. And similarly 1 2 3 4 5, one more possibility should be there. There should be 6, right? So ball 2 2 3 1. So ball 2 ball 3 and ball 1. Is it there? Ball 2 ball 3 and ball 1. I think it's not there. Ball 1 ball 3 it is there. So ball 2 ball 3 2 3 2 3 and 1. So there are 6 possibilities possible. There are 6 possibilities. Okay. Interesting. The next question: what if we had 4 balls instead of 3? As it turns out, listing out all possibilities will become quite tedious, obviously. And if you try listing out possibilities for 5 balls, it may take you more time than an hour or two. So we need to come up with something better. Let's say 4 balls are, and we put A as the start of the line. What remains is mixing up 3 balls for the remaining 3 spots. So we could begin to calculate that, but wait, we already did that above. Indeed, there are 6 ways of lining them up. Okay, there are 6 ways of lining them up. But what if A isn't at the start of the line? A isn't at the start of the line. What if A isn't at the start of the line? Well, some balls has to be at the start of the line, and it's not A. So let's say it's B. Then we need to arrange A, C, D for the remaining 3 spots. There are 6 ways of doing this too. In particular, you get the same for each ball at the start of the queue. So the total number of ways of doing so could be 6, 6, 6, and 6. Obviously, any spot we can have 6 ways of keeping here. There are 4 balls only. Okay. So if the first spot is fixed for 4 balls and 3 can be interchanged, so there are 6 possibilities. Okay. One is fixed, 6 possibilities. Second is fixed, 6 possibilities. Third is fixed, there are 6 possibilities. And fourth is fixed, 6 possibilities. Use this to figure out the answer to 5 balls. So let us we could begin to calculate that, but we already did that. Indeed, there are 6 ways of lining them up. But what if A isn't at the start of the line? Well, some ball has to be at the start of the line, and it's not A. Let's it be. Then arrange A, B, C, D for 3 spots. There are 6 ways of doing so. In particular, you get the same each ball as the start of the queue. So the number of ways of doing so will be this much. And I think uh, for 5 balls, we'll have. Let us say the question says that find the use this to figure out the answer to the 5 balls. For 4 balls, I think one is fixed and other 3 are you can say we are finding out. So other 3 will lead to 6 ways. 3 balls can be kept in 6 ways. That's fine. And similarly, other 3 again will lead to 6 ways. Okay. So one is fixed, other 3 will be lead to 6 ways. One is fixed, other 3 will lead to 6 ways. So like this we have to find, we have found for 4 balls. 4 balls, now what is the, and let if you put A at the start of the line, obviously there are 5 balls. If you put A at the start of the line, so there are 4. So for 4 balls are there and A at the start of the line. For 4 balls we have uh, 4 6 are 24. So basically for 4 balls, what logic I can say we used here is for 4 balls, so it is 6 into 4, that is 24. For 5 balls, 6 into 5, that is 30 can be the answer. We'll just check it. 654. Okay, let me just check it first. If A is a star, there are 24 possibilities. Then that is not the correct answer then. For 4 balls, we have 24 possibilities. Okay, that is a correct way. For 5 balls, for 4 balls, we have 24 possibilities. For 3 balls, we have 6 ways actually. For 4 balls, we have 24 possibilities. For 5 balls, we have 24 into 5. That will be, because 4 balls has 24. So if one is fixed, 4 will have 24, 24, 24, and 5 balls are there. So 5 times it will be, okay. Because it is one is fixed, let us say A is fixed. Let us take an example like A's example. A is fixed, then it is very, very clear, then 4 have 24 possibilities, okay. 24 possibilities. And similarly it can go to other places also. Yes, right now A is fixed, it is B is fixed, C is fixed, D is fixed, E is fixed. So that's why 24 into 5, that is 120 is the answer here. And if you're going for find answer when there are 10 balls, so for 6 balls we have 120 into 6, that is 0, 12 to 1 carry, 6 on 6, 720. For 7 balls we have 720 into 7, that is 0, 4, 1 carry. It is 5040. For 8 balls, we have 5040 into 8, that is 0, 2, 3, and 40. Okay, it's a very big number now. Similarly, we can find the 9 balls. We have 4, 1. It is 40, sorry. So 40320 into 9, that is equal to 0, 9 to the 18, 1 carry, 28, 2 carry. So 9 for the 36. We have this number right now. So okay. Now for 10 balls, it will be 362880 into 10, that is directly equal to 3628800, and this can be the answer for the question of 10 balls. Let me check it. It is 207. Notice that instead of doing we could have simply multiplied. Similarly, in the previous subpart, we could have 25 into 5. Okay, and 93. The answer for 6 ball is this much. Okay, that's correct. And 565. It's a very unique way of writing. Okay, this book is written in a very unique way. 565 for 10 balls. For 10 balls, we have 120, 6, 7, 8, 9, 10. That's correct. I think the answer is correct. This answer is correct. Okay, this is a very correct answer. So this question is done. Things are beginning to get messy, and there are a couple of questions. Why did we do 6 plus 6 plus 6 plus and not say 6 dot 6 dot 6 dot 6 dot 6? Do we always need to add things, or are there cases where we need to multiply or divide? Obviously, that is a very good question. It's important we try and strengthen the basics of a little bit little bit before moving forward. As it turns out, all of counting can be reduced to two basic principles as follows. The principles are addition and multiplication principle. Addition principle is there, multiplication principle is there. We'll just get back to this after, you can say, after some time. Okay. So it is page 8. I'll just write somewhere. Okay. So here, some questions I've done. This question is done. This question is done. So we'll come back to this particular part, not right now, but after maybe some break, etc. Okay, I'll just